This conference will now be recorded.
No, I think we are good so far. Um, Naren,
Okay,
you.
Naren.
No, 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 no.
Okay, fine. So today we are going to discuss on the load balancer. So let us discuss on the load balancer. Then what is a load balancer? What type of load balancers are available? Let us discuss. Fine. So now here, let me start sharing my screen. Fine. So you guys can see my screen.
Yeah.
Yeah.
Okay. So let us say I have a EC2 instance. Okay, fine. So this is where my application is deployed. So this is where my application is deployed, and this is the only server where my application is deployed. This is the only server where my application is deployed. So now what happens here? Every user every user is basically accessing the application to this IP address or the domain name, whatever it is. Okay, because all the traffic coming from all the users across the world has to go to this server. We have only one server that is available, there is no other option. So every request comes to this server. Now every server has its own capacity to handle the traffic. Like if you take any server like google.com or amazon.com, any servers, they have some capacity to handle the traffic. So assume that this particular server where we deployed our application has the capacity to handle 5000 concurrent requests. That is 5000 users can access the application at the same time. So that is where its resources are reached to 100%. When the 5000 users is the full capacity of the server, it reaches the CPU utilization 100% or memory or disk space, whatever it is. At least the CPU utilization is what I can say. It reaches the 100%. So now when you are getting the more traffic, let us say I'm getting the 6000 users or 7000 users, if I don't take the action immediately, my server is going to be crashed, my server is going to be shut down, or my server is going to give the very slow response. So to avoid that, what we are going to do here, we will add one more server. We will add one more server here. So I added one more server, and in this server also, what we did, we have deployed the same application. Currently, my application is running on the two servers. My application is running on two servers. So now, when the users are accessing the application, when users are trying to access the application, where the request should go, user request should go to server 1 or server 2. We should have some mechanism to handle these user requests. So that is where we are going to use the a load balancer. Okay, so we are going to use the load balancer in between. So this is the load balancer. So then what will happen? All the user requests comes to the load balancer. Then load balancer decides whether the request goes to the server 1 or request goes to the server 2. Okay, so there are what is that? Normally it is going to look at what is the server that is serving the what is it, less load, that is having the less number of requests. For example, the server 1 is having only 1000 requests, server 2 is having 2000 requests, then the next request is going to send it to the server 1. That means load balancer is the one responsible to share the load equally across the available servers. So this is the concept of the load balancer. Now, if you look at the technical terminology, if you look at here, these are the what we call it as the targets. What we call this as the this is a target group. Okay, this is a target group, and these are the targets. Okay, fine. So if you look at here, these are the targets, and this is what we call it as a target group. target group here. Okay, fine. So now here your load balancer is going to perform a health check. Your load balancer is going to perform a health check. How it is going to perform a health check here? It is going to ping these servers continuously in the sense you can provide what intervals like every 30 seconds, every 1 minute, every 5 minutes. That is something you can give the intervals. Assuming that every 30 seconds is the interval, that means your load balancer is going to ping the server one, and it is going to see if the server is reachable, and similarly if it is going to ping the server two, it is going to verify if the server is reachable. Then uh, then it marks that instance as the healthy. So every 30 seconds or whatever the interval that you set, your load balancer is going to perform the health check on available targets, and it is going to mark them as the unhealthy or healthy. So when you are doing the configuration, you can basically you can set up what is the healthy thresholds. What is the healthy thresholds? Healthy thresholds, unhealthy thresholds, okay, then interval, okay, then interval. And what is the healthy thresholds here? It is not like when I ping the server is reachable, I cannot confirm that healthy. So it is going to ping the server continuously 2 times or 3 times or 5 times. Again, these are all the configurable values which you can configure within the ranges. Assuming that I set this as the 5, that means my load balancer is going to ping the server 5 times. Ping the server 5 times, and within these 5 times, if the server is responded properly, then this marks that instance as a healthy. And for example, let us say this pinged the server number 2, unhealthy thresholds also I set it as the 4. Let us say I set it as the 4. This I set it as a 5. So now unhealthy thresholds, let us say my load balancer pinged the server number 2, and it did not give the proper response, or maybe it did not at all given the response. It continuously pinged the server 2 4 times. If it is not received any response, or if it is received bad response, then it is going to mark this instance as the unhealthy. So now in this case, assume that your load balancer is marked instance number 1 as the healthy, instance number 2 as the unhealthy. Then what will happen? All your requests, load balancer is going to send it to only healthy instances. Only healthy instances. It is not going to send the request to the unhealthy instances. Fine. So that is the reason why we are going to perform the health check here. Fine. So now, if you look at what are the kinds of the load balancers available in the AWS. Initially, when the AWS was introduced, there is only one load balancer called the classic load balancer. Classic load balancer. This is the only load balancer that is available initially. Now, later, it has been divided into classic load balancer has been divided into application load balancer, then a network load balancer. Okay, network load balancer. Okay, so then they have been divided into application load balancer and the network load balancer. So when this has been divided into application load balancer and the network load balancer, so now classic load balancer is no one is using this. No one is using this. That is what we call this as a previous generation load balancer. We call this as a previous generation load balancer. So we are not really using this nowadays. We are not using this, but this is still available for a backward compatibility. Okay, and later they have introduced one more load balancer called the gateway load balancer. Okay, gateway load balancer. So finally, if you look at here, there are 4 types of the load balancers are available here. Okay, fine. Now You guys are aware of the layered architecture?
You mean application layer and stuff like that?
Yes, yes, yes. Application layer, presentation layer, transport layer, network layer, session layer, data link layer. See, basically, why we are discussing this layered architecture here, it is, if you look at, okay, so if you look at here, for example, let us say, I have the system one. This is the system one, system or device, whatever it is. And I have the system two. Let us say any systems, any two devices or any two systems in the world is communicating. The only reason is exchanging the data. Okay, the only reason your systems and my system is communicated through the go-to meeting. What we are doing, we are exchanging the data. So any two systems in the world are connecting to exchange the data. So when the data is getting exchanged, it is exchanged through the 7 layers. 7 layers are going to participate in the data exchange. Like those layers are what we call it as the OSI model. That is the open system interface, like a open system standards. Yeah. So this open systems interconnection, OSI data model, open systems interconnection. It is a OSI data model, ISO standard for computer networks design and function. So in this, what it is going to do, it involves at least 7 layers, each playing a specific role when applications are communicating over the net. During the sending process, each layer from top to down will add a specific header to the raw data. At the reception, headers are eliminated conversely until the data arrived to the receiving application. Only the intention, the purpose here it is the data is received safely. The data is received accurately and safely. Okay, the no data is lost. Okay, fine. So now you can look at here application layer, applications connected to the network, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. So now here, how we are going to look at physical layer is the first layer, data link second, network third, transport 4, 5, 6, 7. So application layer is a layer number 7. So that is how we are going to look at the numbers. So what is that each layer is going to do? You can look at here application layer. It contains the applications which are used by the end user such as Java, these things. Request is initiated from the application layer. Presentation layer is responsible for encrypting the data, formatting the data. And similarly, session layer is the responsible for managing the session. And transport layer is the one responsible for data segmentation, where data can be divided into packets. Okay. So all these are the, what is the purpose of the layers here? So why I am saying these layers are basically, when I say load balancers, application load balancer and the network load balancer, this load balancer is works based on the application layer. Based on the application layer, this load balancer is going to work. Similarly, network load balancer is going to work based on the network layer. Okay, based on the network layer. Then the gateway load balancer is again it is a completely newly load balancer. This is works on the a specific protocol. Specific protocol, that is something I'll let you know. Uh, Specific protocol. Then
Something to do with
when
NAT gateway and other things?
yes, yes, it is related to completely internet gateway and the NAT gateway where you can balance your loads. But the protocol, what it is going to use here, it is I don't remember the protocol. Where is this? Gateway load balancer. It is using the this works at layer 3, and yes, this is the Geneva protocol. This is a Genevieve protocol on port number 6081. So this is a protocol it uses. Okay, fine. Now, first thing is initially application and the network load balancers are available in the classic. So then there is what is that? There is nothing to discuss about the classic load balancer. When it comes to the application load balancer, normally any request coming from the HTTP or HTTPS, HTTP or HTTPS, any request that is coming from the HTTP or HTTPS, for example, you have the application, your application is getting the requests from the HTTP and HTTPS, then it is preferred to use the application load balancer. Okay. See, as per the AWS recommendations, what it is saying here, it is, for example, if you go to the security group, normally HTTP and HTTPS ports are the reserved ports. That is the port number 80 and the port number 443. And you also have the custom ports. Let us say my application is running on the 8080, 9000 or 10,000, whatever it is. Okay. So what AWS recommends here, it is any request is coming from the HTTP, HTTPS, you can use the application load balancer, and any request coming from the custom TCP ports, you can use the network load balancer. That is what the AWS recommends. But you can use any load balancer. You can use either application load balancer or the network load balancer for to load balance your application. But there is a difference here. There is a difference. Application load balancer has more features, which is not available in the network load balancer. So, what are those features? At least a couple of features are the path-based routing, path-based or host-based routing. Host-based routing. What does it mean? Let us take the same scenario here. Okay, let us say this is my application. My application, maybe assuming that this is simple, my e-commerce portal application, and my application is running on the two servers. Okay, on the two servers. So if I wanted to enable the path-based routing, let us say I have some more servers. I have some more servers. Okay, this is another server, and this is another server. So let us say I have the total 4 servers. But out of these 4 servers, let us say this is where my application is running. Application is running here. This is also where my application is running. And this is where all my images are stored. All my images, like a logos, or maybe it is your product images or your company logos, whatever it is, all the images are stored here. And this is where all my static files are stored here. Static files are something like a CSS files, JavaScript files, HTML files. All these are the static files. Okay. So basically, this is one way of improving the performance of your application. You're just reducing the burden on your application servers by distributing the load, or by distributing the storage into the different segments. So now, if I enable the path-based or the host-based routing, so let us say the request comes maybe HTTP, some domain name, okay, some domain name, localhost. Assume that localhost, domain name slash, okay, company dot jpg, okay. And similarly, there is another request, HTTP colon slash slash localhost, then localhost, then slash, okay, services dot html. Okay, fine. Now, if you enable the path-based routing, if you look at here, whenever the request is coming to check the image. Then your request straight away, your load balancer is going to send the request straight to this particular what is that server where all the images are stored. In this case, you are looking for the static file. The request directly goes to this particular server. So this is what we call it as a host-based or the path-based routing. If you wanted to use this feature, you have to use the application load balancer. You cannot use the network load balancer. Okay. And what is the second feature that is available in the application load balancer, which is not available in the network load balancer? Sticky sessions. Sticky sessions. So now when I say sticky sessions, what does it mean? Let us say user is sending the request. The request may go to the server 1, may go to the server 2. We don't have any control on that request. But I wanted to have the control on the request. My request always goes to the, my request, I want my request to go to the server 1 always, or my request wanted to go to server 2 always. That means my request has to stick to some server always. Okay, fine. So this is where basically you can enable the sticky sessions. Once you enable the sticky sessions, what you can do here, you can basically whenever your request is coming from that particular user or maybe particular domain or particular IP address, and your request always goes to the either server 1 or server 2. This is the a sticky sessions. So, and what is the other features available? Application load balancer can use a dynamic IP address. That means it don't need any static IP address. And network load balancer needs a static IP address. So these are the some of the differences between the application load balancer and the network load balancer. So if you really wanted to use these features, you have to use the application load balancer. If you really don't have any preferences, I don't need these features, then you can go ahead with the application load balancer or the network load balancer. Fine, you guys are clear?
So for
Yeah.
network load balancer, you have anything specific?
What
Okay.
is that?
Network load
Network
balancer is
load
kind of plain.
balancer, there is nothing. But again, what AWS says here, it gives the what it says. It gives the best performance compared to the application load balancer for the custom traffic. Normally, if you look at here, traffic coming from the TCP UDP protocols. That means ideal for the load balancing on both TCP and UDP. That means whatever I say, custom TCP. Okay. So this is capable of handling millions of the requests per second while maintaining the ultra low latency. So this is what AWS says. Definitely, this is a faster than the application load balancer, but the features what we discussed is not available here. Okay, so it's optimized to handle sudden and volatile traffic patterns while using a single static IP address per availability zone. Okay, fine. So definitely this gives the best performance, but if you really wanted to use those features, those features are not available here. Fine.
Recently,
Now,
we had a situation where we had custom SSL. So if you want to use custom SSL, then we can only use it through ALB.
yes,
Uh,
that is also one other option where SSL offloading is not available in the network load balancer. You need to use the application load balancer. Okay, so you can. These are the differences that we have captured here. You can look at here. Preferred protocol application load balancer HTTP HTTPS network load balancer TCP. So then SSL offloading application load balancer yes, network load balancer no. Targets. Targets is what we discussed here. These are the targets. Targets can be a EC2 instance, can be IP address, can be a Docker containers, can be a what is that? Targets can be anything here in both the load balancers. Targets can be anything. Then path-based, host-based routing, application load balancer offers, network load balancer don't offer. So these are all the differences, but at least the three differences what we discussed is when you wanted to use those features, you can use the application load balancer, but not the network load balancer. Fine. So before I do the lab, any other questions here?
No.
Uh, gateway load balancer is so gateway load balancer also works through targets, or is it like
Gateway load balancer, it works. So the traffic is controlled through the gateways basically. So this let us look at the flow diagram here. Yes, yes. It is also a target groups. It is also a target groups, but the load is balanced from your gateways, like a internet gateway, VPC, and the route tables. The load is balanced through that. So in this case, your application, the network load balancer, the load is balanced from the load balance, from the load balancer, and directly sends to the targets. So in this case, the load is balanced through the route tables, VPC and internet gateway. Uh, you can look at here. You can look at the flow diagram here. Routes requests to a target group consisting of a scalable fleet of applications. For example, firewalls, deep packet inspection systems, URL filtering systems. So it's depending on what is that? Your gateway load balancer process the traffic, and it is decides which uh, to which target groups it has to send the traffic.
the target group
Uh,
can be anything, right? It can be
Target,
any
yes, yes.
service.
Target group can be anything. Target group can be anything. So if we look at here, this is your route tables. This is a route table configuration. So yeah, this is a route table configuration here. So these are the application servers. This is your gateway load balancer endpoint. This is your gateway load balancer, and this is the appliances availability zone. Okay. So this is at the route table level, you can control it basically. You can create the gateway load balancer and the route table level. For example, let us say traffic coming from these IP address ranges can go to this particular gateway load balancer. So something like that, you can configure this at the gateways level.
So for
Gateways
example,
level.
I can have one gateway behind that behind sorry, before a load balancer like application or network load balancer, and then have my application servers sitting. I mean, just I'm trying to understand like where gateway would be useful.
Okay, fine. See, first thing is you guys understood this diagram.
Yeah, yeah.
Oh.
Okay, fine. See,
I mean,
basically
when it's
here,
EC2, it's probably simpler, but
yeah, 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 yes, yes, yeah. Now, what I'm
if it's
trying
some
to
other
say here
service,
it
maybe
is, yeah, yeah.
yeah.
So now here, let us say user. This is the user. User is sending the request. The request comes to the application load balancer. This is what we see here. But again, here, here between the user and the application load balancer, there are a lot of other components. There are a lot of other components. What are those components here? We have the uh, we have the VPC. Okay, we have the VPC. We have the internet gateway, and we have the route tables. Okay, and your request has to pass through all these things. Your request has to pass through all these things, but in this case we are assuming that there are no restrictions there. There are no restrictions there at the VPC level
Yeah.
or the route table level or the internet gateway level. We don't have any restrictions. That's where we are assuming that our request came to the application load balancer. Then application load balancer is going to decide where it should send the request. But when you use the gateway load balancer, you can control the traffic at these levels. Your route table level, or maybe your application load balancer. What is that? Internet gateway level here. Okay, fine. So now if you look at the flow here, probably when we discuss the VPC and route tables, so that time probably we can discuss the gateway load balancer again. But if you wanted to just understand at the high level, what it is going to do, traffic from the internet to the application. Okay, how the traffic comes? Traffic enters the service consumer VPC through the internet gateway. This is the first entry point into our domain. Okay, then traffic is sent to the gateway load balancer endpoint as a result of ingress routing. Traffic is sent to the gateway load balancer for inspection through the security appliance. Traffic is sent back to the gateway load balancer endpoint after inspection. First is traffic is validated, whether this is the authorized or not, this is secure or not. It is going to validate it and it's sent back to the gateway load balancer. And now load balancer is again going to send the traffic to the destination. Okay, fine. So probably we can come back this once we discuss it on the VPC.
Okay. Yeah.
Okay, you guys are okay?
Yeah.
Yep.
Okay, fine, fine. So now let us do the lab here. Let us do the lab. Naren, are you okay?
Yeah. Yeah.
Okay, fine. So let us do the lab. What we are going to do first, let us create the targets. Let us create the targets. Then we are going to create the target group. Then we create the load balancer. Then we'll try to access the application running on the targets. So let us prepare a user data. Let us prepare a user data because we need a sample application to be running. So let us look at, this is my user data. So in this, what are the things I need here? I am saying instance hyphen 01. Okay, instance hyphen 01. Okay, then I don't need the git here. So here I'm installing the Apache, and this is my default landing page, and this is my start command. This is my enable auto start. So I'm going to copy this. What I'm going to do here, first I'm creating the targets. First I'm creating the a targets here. Okay, launch instance, and I'm giving the name also instance 01, instance hyphen 01. Okay, fine. So selecting the red hat here, selecting the red hat, then the same thing, free tier eligible, instant type t2.micro, then the key pair, existing key pair, and existing security group, existing security group here. And here advanced details, I'm adding the user data section here, user data here. Okay, fine. So now I'm simply launching the instance. While this instance is getting launched, I am going to create another instance because I need a minimum 2 instances to the load balancer. Instance hyphen 02. Okay, then selecting the same red hat and key pair and existing security group, existing security group, and here advanced details. Okay, okay, fine. So here I'm doing a small change here. I'm doing a small change. I'm changing this to instance number 2. The reason is when my request is going and accessing, Whether my request is going to the server 1 or server 2, I need to identify. So that's the reason I just changed the text. Okay, I just changed the text here. So here, okay, instance number 02 here. Hope I have given the name also. Name to the instance. Okay, fine. So that is the only change I did, the text, just to identify where the request is going. So now I'm going to launch the instance. Fine. So now I have the two instances. If I wanted to access the application running on these two instances, I need to use a public IP address of the each instance. Okay. So now targets has been created. Then what is the next? Target group. So if you come down the left side, there is a target group here. Okay, target group. Create a target group. So you can look at here, what is the targets? Your targets can be instances, IP addresses, and the Lambda functions, and your application load balancer also can be your targets. Okay, so these are all the targets, but in my case, instances is the targets. Then what is the application load balancer? What is the target group name? Okay, maybe I can say target group -01. This is my target group name. And what is the protocol? What is the protocol that you wanted to allow the requests coming in? HTTP is a protocol. If you wanted to add HTTPS, other protocols, you can add it. But if you wanted to add the HTTPS, you need to have the SSL certification. Okay. So this is the protocol. And what is this? What kind of IP address you are accessing? IPv4. Okay. Then I'm using the default VPC, and these are the HTTP protocol version. And here, these are the health checks. So how the load balancer is going to perform the health checks? It is going to ping the server. What is the path? I can give the index.html. We already have the index.html file. So it is going to ping the index.html file on the server 1 and the server 2 to see if there is getting a response. And these are the parameters, advanced health check settings. This is all what we discussed. Like healthy thresholds, there is a 5. You can change up to 10, between 2 to 10. And unhealthy thresholds, there is a 2. You can set up to between 2 to 10. Then the timeout is nothing but if you don't get any response and within 5 seconds it is going to time out. Then you have the interval, how frequent it has to perform the health check, 30 seconds. Then what is this? Success code. This is a HTTP status code. So when the ping is success and it is going to give the HTTP status code 200, that's what I'm confirming that my status is healthy. So these are all the advanced health check parameters. If you want, you can change it within these available ranges. So then tags, we know what is the tags is about. Next, and register the targets. I created the target. I'm creating the target group. You need to register the targets. By default, all the running instances are populated here. I'm selecting both the instances. Include as pending below. So this is how you're going to register the targets. Then create a target group. So now my target group is created. You can create any number of target groups. In a target group, you can have any number of instances, endpoints. So now the target group is created. Then now let us go to the load balancer. Where is the load balancer here? Load balancer, load balancers. Here, create a load balancer. So now we can look at here, application load balancer, network load balancer, gateway load balancer. Then you have the classic load balancer. This is a previous generation load balancer. This is a combination of the application and the network load balancer. Okay, fine. So now I'm selecting the application load balancer, create. Then what is the load balancer name? Maybe you can give the, okay, my ALB ALB-01. Okay, internet facing. Okay, or you can give any name here. Internet facing, yes, this is the internet facing. And internal also you can create basically. Again, if you, what is that? If your traffic coming from the gateway load balancer is directing the traffic to application load balancer, you can make this as the internal. Okay, so then IPv4 address, IP address type, what it is, basically allowing IPv4. Then the network mapping. So here, this is the default VPC, and when it comes to the mapping, availability zones. Availability zones is nothing but where is your targets? Your targets are in which availability zones. If you know which availability zone your targets are there, you can select that particular availability zone, or you can select all the availability zone. There is no harm here. Okay, there is no harm selecting all the availability zones. If you are sure that your targets are there in particular availability zone, you can select that particular availability zone here. Then what is the security group? Default security group. Then listeners and the routing, you can look at here. Request is coming from the HTTP protocol on the port number 80. The requests are going to be redirected to the target group. What is the target group? This is a target group. And the target group, there is a targets. Okay, so this is how the requests are going to be redirected to the targets. Then what else I have here? Web application firewall. This is something we discussed when we discussed the S3 CloudFront. When we discuss the CloudFront, we discuss the web application firewall. This is where you wanted to a kind of a blacklist and whitelist. I wanted to blacklist these IP addresses. I wanted to allow the traffic only from these IP addresses. A kind of a whitelist and a blacklist is something you can create using the web application firewall. Okay, fine. So then global accelerator is another acceleration service, another caching service, where to enable the to speed up the data transfer. Again, these are all the additional charges. And what else I have? This is all the overview and whatever we have selected till now. And what are the other options that I have here? Server side tasks and status, creation, workflow, and status. Okay, server side access and status, create a load balancer. Okay, this is the information. Actually, it is giving the information, not started the load balancer. Okay, listeners. Okay, fine. So I'm just creating the load balancer. Fine. So my load balancer is getting created, and it is going to give the yeah, it is provisioning. The status is provisioning, and it is going to give the, you can look at here, DNS name. DNS name. This is what the URL or endpoint to access the. Okay, this is what we can access basically our load balancer. Okay, fine. So now if I go here, I think mine is still provisioning. Still provisioning. Maybe let us wait. Okay, it may take a minute. So if I go here, if I open it, this is our. Okay, it is still provisioning actually. It is still provisioning. Let us wait for a minute.
So what is that separate concept of listener? I thought listener is like this load balancer is listening to any HTTP request which is coming in through that DNS, right?
Yes, 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 yes. That's a true. But again, if you wanted to add the multiple listeners is something. I wanted to listen the traffic coming from the HTTP port, coming from the HTTPS port, or coming from the custom TCP port. These are all the listeners.
Okay.
So
Within a load
here,
balancer, I think we can have multiple listeners.
Multiple
yeah,
listeners
if you look
within
at
the
here
load balancer.
HTTP,
Okay. In default, it's only HTTP because we selected that.
yes,
Okay.
yes, yes. If you wanted to add the listeners, you can add it. I wanted to add HTTPS, you can add it.
Okay.
Yeah, I think when we were
Fine.
creating this load balancer, it asked what
Yeah,
listener.
even
Yeah.
now also, now also you can add it. Now also you can add it. You can add while creating it or maybe after it created. Fine. So now if you look at here, my request went to server number 2. My request went to server number 2. I am again refreshing this. I am again sending one more request. So let us see. This time my request went to server number 1. So your request is going to server number 1 and the server number 2 here. So that is what a load balancer is basically managing the traffic to split across the targets equal. Across the
Can you
targets equal.
stop instance 1 or 2 now?
Yeah. If you stop the instance, your request always goes to the available instance. So what I'm doing here, let me stop the instance number 2. Instance number 2, I'm stopping it. Okay, stop the instance. Okay, fine. So when I'm stopping the instance number 2, if you look at here, when I'm refreshing, my request is always going to instance number 1.
It's stuck, right? Huh?
It's again, it's processing. It's processing. Uh, you can look at here. So it's always going to instance number 1.
So gateway timeout happened because 2 was down.
2 was down, gateway, but it should not go to
30
there
seconds.
actually.
Or even here.
Yeah, you can look at here. Yeah, yeah. See, it's always, see, initially it might be taking because the
We put the
instance is
timeout
still,
time 30 seconds. We put that there. So it's
yeah, it's still stopping actually. Once it is completely stopped, in the next cycle of the health check, after the interval 30 seconds, then it should go to your instance number 1. Within the 30 seconds, it might be trying to reach that instance number 2 also. That is the reason where you see the bad gateway time. So now if you probably if you want, you guys also can try this. I'm sending in the chart. So your request always goes to instance number 1. It should not even uh, it should not even know that the instance number 2 is available.
hmm.
So fine, you guys are clear.
Yeah.
Okay,
Yeah.
fine. So yeah, so similar way, if you guys wanted to create the network load balancer, you guys can create it. Okay, uh, and then the next topic is auto scaling. The next topic what we are going to discuss is the auto scaling. So any questions before we start the auto scaling?
Now we can proceed.
Fine. Auto scaling. Auto scaling. What is the concept of the auto scaling here? The concept of the auto scaling is scaling. Scaling, what is the meaning of the scaling? Scaling up or scaling down. Scaling up or scaling down. That means scaling up means increasing the number of resources. Scaling down means decreasing the number of resources based on some conditions. How you are increasing, how you are decreasing, based on some conditions, whether you are increasing or decreasing is what we call it as the auto scale. What we call it as the auto scaling. So whenever it comes to the scaling part, we have a horizontal scaling, and we have the vertical scaling. So these are the two kinds of the scaling available, but in the cloud environment, we always use the horizontal scaling. Only in the on-premises environments, we are using the vertical scaling. Of course, even in the cloud environments, we use the vertical scaling, but that is something, it is very rarely, very rarely. So now if you look at here, let us say I have this is my server. This is my server. Okay, this is my server. And my server is having the, what is that? My server is having a capacity of the maybe 4 GB RAM or maybe one 500 GB hard disk, then one CPU. Let us say this is my server configuration, and I have deployed the application in the server, and my application is working fine. And after some time, my application is giving the slow performance. Then you might be thinking that my server resources are very low. I wanted to upgrade these resources. I can increase from 4 GB to 16 GB or maybe 500 GB hard disk to 1 terabytes or one CPU to two CPUs. So this is where we call it as a vertical scaling. This is where we call it as a vertical scaling. So vertical scaling has its own limitations. Has its own limitations. When I say 4 GB RAM to 16 GB RAM, you might be able to increase the to 20 GB or 30 GB or whatever it is, but there is some limitation. You cannot go ahead and increase it to 1000 GB RAM or maybe what is that, to 2000 vCPUs. So vertical scaling has its own limitations, and again, this is not so preferred option in the cloud environment. Of course, cloud environment, when you create the EC2 instance and you wanted to increase the disk space, you wanted to increase the instance type, and that is all coming under the vertical scaling only, but that is very rare scenario. Okay. So horizontal scaling, what is a horizontal scaling? You have a server, and whenever I need more capacity, I'm simply go on adding the servers. I simply go on adding the a servers. Assume that this is my application, where my application is, okay, where my application is running on one server. Okay, my application is running on one server, and when my application running on one server, how we are going to measure the load? What is the load on your server? How you are going to measure? Either you are going to use memory utilization or maybe mainly CPU utilization. Mainly you are going to use the CPU utilization. What is the load that is coming onto your server? So in this case, you are going to monitor your CPU utilization. My CPU utilization is going beyond 80%. Then it may reach 100%. Once it reaches 100%, you cannot your application cannot process the requests. Your server cannot process the requests. That is where you wanted to increase the number of servers. You wanted to increase the number of servers, but again, you really don't want to sit and monitor them manually. You really don't want to sit and monitor what is my CPU utilization. My CPU utilization is 80%. I will add one server, and again, when my CPU utilization is 50%, I will remove one server. All these things you don't want to do it manually. So what is that you are going to do? You are going to set up a auto scaling. So once you set up the auto scaling, what is the auto scaling group? You are going to set up the auto scaling group. When it comes to the auto scaling group, what are the different things we have here? What is the minimum number of instances? Minimum number of EC2 instances. Okay, assume that 1. What is the maximum number of instances? Assume that 4. Let us discuss in detail. What is the desired number of instances? Desired number of instances. Okay, 2. Or maybe a number between min and max. Then what is the target tracking policy? Target tracking policy. Assume that in this case, target tracking policy is a CPU utilization. So what is the condition that you are going to put here? What is the condition that you are going to put here? Whenever my CPU utilization is, okay, if my CPU utilization is greater than 80%, add one instance. Okay, if my CPU utilization is, okay, less than 80%, then remove one. So this is what you are going to decide. Auto scaling group consists of all these things. Your minimum number of instances, maximum number of instances, desired number of instances, target tracking policy, what is the condition? Let us say I have deployed the application on one EC2 instance. Okay, I have deployed the application on one EC2 instance, and my auto scaling group is going to monitor, okay, the CPU utilization. And whenever my CPU utilization is reached 80%, when my CPU utilization is reached 80%, it is going to check whether your CPU utilization is consistent at least for 5 minutes, or maybe whatever the time that we have, maybe 1 minute or 5 minutes. So if the continuously the CPU utilization is greater than or equal to 80% for that period, then it is going to add one EC2 instance. It is going to add one EC2 instance to your environment. So now you have the two EC2 instances. Now again it starts comparing the average CPU utilization of the two instances. Again, when it is greater than or equal to 80%, it is going to add one more instance. It is going to add one more instance. How many instances it can add? Maximum is 4. That is, maximum number of EC2 instances where your application is running is 4. And how we are coming to this number, that is purely up to you. See, it is not one day decision. It is not a one time decision. Okay, depending on your past experience, depending on evaluating the application for some amount of the time, you are coming up with this number, and this is not fixed number. And today you decided 4 instances are sufficient to meet the customer demand, and tomorrow you may change it to 5, you may change it to 6. So you are coming up with this number based on your past experience, based on evaluating the application. So this number, that is where the maximum number of instances can be added to your environment. And let us say after some time your CPU utilization coming less than 80%, then it is going to take out one instance. Again it is going to compare, so it is going to take out one instance. That is, minimum number of instances to be maintained is 1 always. Whether you have the CPU utilization is 0% or less than 80%, you have the minimum instance to be maintained is 1. Okay, fine. And what is the desired number of instances? Desired number of instances is nothing but, at this point of time, I need 2 instances to maintain my load. Depending on your conditions and everything, at this point of time, I need 2 instances to maintain my load. That is the desired number of instances. That is a number between the min and max. And what is this auto scaling group is going to do? Let us say at this point of time, my desired number of instances should be 2 based on the load. But my actual number of instances running is only 1. My actual number of instances is running only 1. Then auto scaling group is going to go and create another instances to meet the desired instance. That is, whenever your actual number of instances is less than the desired number of instances, auto scaling group is going to create the additional instances to meet the desired number of instances. Till now, you guys are clear?
Yeah.
Yeah.
Okay, fine. So last thing here, last thing here. So let us say I created the auto scaling group. I created the auto scaling group, and this is my auto scaling group size. Minimum number of instances 1, maximum number of instances 2. And what is it? My application is running on 1 instance. Then my CPU utilization is went ahead beyond the 80%. Now it has to create the new EC2 instance. And how it is going to create the new EC2 instance? Because you need some information to create the EC2 instance. You need the information like from what operating system I should create the EC2 instance, and what is the instance type, what kind of software should be installed, what kind of security group. You need all that information to create the EC2 instance. When it has to remove, it simply can terminate it. We don't need any information to terminate it. But when you have to create, you need all the information to be available to create the EC2 instance. That is where AWS provides a option called the launch template. Launch template. So launch template is nothing but first you are going to create the launch template. Launch, like how you have created the target group before the load balancer, you are going to create the launch template. Launch template is a read-only template where you are going to provide all the information that is needed to create the EC2 instance by the auto scaling group. So first you are going to create the launch template, and whenever your auto scaling group has to create the additional EC2 instances, it is going to read the information from the launch template and create the EC2 instances. Okay, so first we will create the launch template. We will give all the information that is needed, and if you want to give your own AMI for the launch template, you can give it. So then on the launch template, on top of the launch template, we are going to create the auto scaling group. Auto scaling group is going to read the information from the launch template and create the EC2 instance. This is how it is going to work here. Fine. Till now, any questions?
So when it's scaling up and down, will the instances that is going to create, will that be shut down, or are they going to be destroyed completely, like terminated?
It's a destroyed. There is no shutdown. It's destroyed.
Okay.
See, we don't know when we are going to use it, so it's unnecessarily keep it in the what is it, keep in the parking area. So we are going to destroy it, and when we need it, we are going to create it.
Okay.
Okay, fine. And you guys have 5 more minutes.
Yeah.
Uh, okay.
Yeah, I'm not forcing you, otherwise we can stop here and continue tomorrow.
Let's continue tomorrow. Sorry, I'm already
Okay,
late.
no issues, no issues. Yeah, no issues.
Mm.
And tomorrow what we'll do, we'll create this auto scaling group, and we will see how it is going to work. Okay, fine. So meantime, if you guys wanted to practice a network load balancer, you guys can do it, and let me know if there are any challenges there.
Yeah. Thank you.
Fine.
Sure.
Anything else before we close?
No, I'm good.
I
Thank you.
was able to create the ALB. It's working, so I'll try and create an LB as
Yeah,
well.
yeah. Network load balancer also you can try it, and it should also work. And if there is any issues, let us discuss.
Yeah.
Okay. Yeah.
Thank you.
Thank you, both of you.
Thanks.